Welcome all of you. A very good morning. I will be your moderator for this session. This is for the Global Vision Standards, so the 5 associations, VDMA, A3, CMVU, EMVA, and Jahr. They come together under the umbrella of the G3, and we develop the standards for machine vision. And this session is about the standards updates. So all the standards and information about the same you can find anyways on the International Vision Standards booth, which is B50 in this hall. So after the presentation, you can please come to us when you need more information. So without further ado, I will invite our first chair. He's the co-chair of GenICam for the standards update for GenICam.
So hello, everybody. I think this is still a slide for you.
Yeah.
It's about the schedule. I'm the first one. And it's about GenICam. And GenICam is about 15 years old, so we are quite an old standard, and we are a little bit like the spider in the web of all standards. So I will start. My name is Christoph Zirl. I'm the vice chair here of Marketing and Operations. Since it's a quite old standard, we are mainly in maintenance mode. You see here an overview of all GenICam modules and its status. And as you can see, we have a release package from February this year. And we have some new developments coming on the next slide. You see also, for example, GenDC on the upper half. GenDC is quite new, and you will hear more about it from my colleagues because it's a software standard helping to adopt hardware standards to transfer more complex data. So what's the current developments of GenICam? The main module which is under development is SFNC, so the Standard Features Naming Convention, and the new version 2.7 is nearly ready, will be voted on during November, I would assume it will be available. It's quite ready for release. And in particular, it includes the new OOCI feature set, which you will hear later also from my colleague Werner. The other one is the GenICam device validation. So the question is about how is a camera, for example, compliant to GenICam. This is also a quite interesting module because we will hear about it in next year, definitely, because the compliancy of this standard is more and more important. And I'm sure that my colleagues from the hardware standards will adopt this one in the near future. A new version of GenTL Producer Framework is available as a version 3.2 for all the vendors who want to implement a GenTL implementation. And the next reference implementation of the complete GenICam standard, mostly the Gen API reference implementation, will be available, I would say, beginning of next year. It's not clear, the schedule is not clear. And the last point is that the group itself, we are still a 15 years old group, and now it's time finally to re-establish our connection with our host, so with the EMVA. So we are still doing the final preparations for the legal paperwork. So this does mean that the GenICam group will have a new working rules, and you have then to reapply for group membership, I would say, end of this year or beginning of next year. That's all, I think, regarding GenICam.
Thank you, Christoph. The next speaker would be then Werner Veit from EMVA. And you'll be presenting first EM Vision. Yes. Yep.
Okay. Hello, my name is Werner Veit from EMVA, and I'm doing the presentation for EM Vision on behalf of Thomas Rück, who is the chair of the EM Vision group. The EM Vision group purpose is to enable industrial solutions.
Please take a seat.
Yeah, in industrial solutions, embedded solutions in the machine vision world. Right now, the members of the group are Adimec, Alight, Vision, Alysium, Eveldata, Basler, Baumer, Euresys, Fleur, Framos, and so on. I think you can read them. So it's a group out of the bigger GenICam group, out of the hardware standards, but there are significant differences in implementing these, let's say, PC-based standard and embedded standards, and this is what we try to do. The overview of the activities, we have, let's say, 3 major areas of discussion. The maybe most prominent right now is a so-called API, Camera API Exploration Group, which is organized by Kronos jointly together with EMVA. Kronos is a standards group in US, which is hosting, for example, OpenGL or OpenVX, and which tries to port standards into ASIC design. The work there was around presentations, so we call it use cases. The different people presented different embedded use cases so that we can find common ground and a common scope of work someday, somehow. We discussed wording, as words we use in machine vision are maybe not used in ASIC design and vice versa. So the 3 or 4 big groups in that business are the Kronos standards, the Linux kernel developers with video for Linux, it's the Android mobile phone group, and it's us as the machine vision group. And so we have different names for the same things, and we need to sort this out. And what was just decided next week and what's going to start the next days is a statement of work, which will be done by the Envision group. So this is the volunteer to do that statement of work. And of course, you are all invited to participate. We had a user level API discussion as well. What is this? One big thing and one important thing in GenICam was the discoverability of cameras and the self-describing, so that the camera says, this is what I can do and this is what I offer to you as a user. And this part was hidden or was built up in an XML file. This XML file is a bit of a problem in embedded solutions because browsing XML is difficult, and so we are working on a proposal to run XML without XML. And of course we have the common driver discussion which is going on, and there you are invited as well. That's it for Envision.
Yeah, you will carry on for the next one as well?
The next one I do as well on behalf of Eric Widding and Marcel Nagatz from the Open Optics camera interface. Sorry, this is a typo, which Christoph already mentioned out of SFNC release 2.7. What we did there is as well define feature names, so do that SFNC proposal. And right now we are in the start, in the phase of defining a physical interface, so how, not a C-mount interface or so for the optics to the camera, but what kind of pins, electrical pins do we need to program the lens, so the focus, the aperture, the zoom, and what is inside the lens. This work starts right now, and it should be done until or during the next IVSM, and then the work will start to implement GenCP, which you all might know from Camera Link. So some of the old Camera Link cameras are built on GenCP, and now the same protocol is used to program the lens and the aperture and the filter wheel and whatever you can have in front of a camera. Yeah. As said, current tasks define the physical interface, which is very likely to be a UART together with GenCP, but maybe it's an I2C bus as well, to have multiple devices attached to a camera. UART is only a single device. And then GenCP is a bigger step in software, and as this is kind of remote work you could do as well, again, contributors from the industry, from the camera world, from the optics world are invited to join in.
Thank you. Thank you, Werner.
That's
I think the next one is then Über. USB 3. I would just request the presenters to keep it tight, short.
Okay.
2 minutes.
So welcome to this update. Does it work?
Yep.
Ah, okay. Welcome to this update. My name is Uwe Hagmeier, working for Matrix Vision, and I'm the vice chair of the USB 3 Vision standard. I'll present current status of the standard and the next steps. Our latest release is 1.1, which basically, it adds multi-stream support, so it allows to have a camera send several streams in parallel. We added USB 3.2 compatibility, which is basically not a new protocol, but just, let's say, new speed indicators for the faster speeds, which are supported by the USB 3.2 standard. We added new plus connectors, which allow for longer cables. So longer cabling typically needs thicker wires for several electrical reasons. And to accommodate these thicker wires, we need bigger connectors. And so we needed a new specification for that. And also, it adds a lot of clarifications, erratas, fixes to make the protocol even more robust and the specification more clear to use. The next planned update to the specification will be 1.2. And the most important thing, of course, is to add GenDC support. GenDC is a specification from GenICAM, which allows for transport-independent data. It's kind of a container which is specified independent of the transport layer. And this brings us new complex image formats like 3D, compression. And the nice thing is that this will be transported in the same, or it will be stored in the same way for several different transport layer standards. Yeah, the final draft version release candidate is expected to be available soon. Okay, and then upcoming initiatives. There is USB 4 coming or already defined. USB 4 is not just a faster USB 3. It is an adoption of Thunderbolt 3 technology, which allows tunneling several protocols over the wire. So it's kind of a multiplexing protocol. You have USB DisplayPort and PCI Express multiplexed on the same physical channel with a 40 gigabit transport speed. And this allows us to define a new protocol based on USB 4, which basically uses PCI Express, which gives us much more flexibility in the way we transport data and overcome some of the current limitations of USB 3. Nice thing is that, of course, the USB 3 cameras will also work on USB 4, but with the new protocol, we have new possibilities to do more advanced cameras, streaming schemes. Yeah, currently there exists a white paper inside the committee, and we are working actively on creating that standard. I think that's it.
Perfect. Thank you, Uwe.
The presentation was made by Eric Ross, which is the chair of the standard.
Thank you. Next, I would like to invite Dr. Sabine Ott for CLHS.
Auf den Grenner.
Ja.
Okay. Hi, my name is Sabine Ott. I'm from the company PCO. And today I'm representing Michael Mietig. And I'm doing this short overview and update on behalf of the Camera Link HS, or Camera Link High Speed Working Group. So what are the advantages of Camera Link HS? So it's a high-end, low-cost machine vision interface standard, and it's designed as a comprehensive machine vision application optimized protocol with lowest protocol overhead. So the X protocol itself has been unchanged since its release in 2012, and it will remain unchanged moving to 2025. It has a forward error correction 64B, 66B coding implemented, as well as a low trigger latency with zero jitter suitable for high-frequency line scan applications and short exposure area scans. So together with the CLHS protocol, a low-cost fiber optic over long distances can be used for high-speed transmission. All variants are suitable for direct connection to low-end FPGAs, meanwhile up to 16G transceiver, as you can see here for the fiber optic version. So also copper can be used, and for this, the current standard is up to 10 gigabytes per second at a line rate of 12.5 gigabits, which you can see below. Yeah, for the copper version, asymmetrics cables are used with 7 lanes downstream and 1 lane upstream, which is perfect for high bandwidth image processing because of the capability of data forwarding. So what brings the future? 25G is in the final step for release, leveraging a 25G Ethernet hardware. And there is no change in the X protocol. This can be used as well as it was used before. The IP core or user logic, there's no change as well. It's just about increasing the system clock. And all timings are or can be met easily in a 25G capable FPGA. So there are new connectors added to the interface standard. So this is an MPO or QSFP plus connectors, and they will support 4 times 25G, so in total 100G over one single cable. So what's coming next? Currently the working group is defining the 50G speed grade, and the goal is only to define minor changes in the IP core, and 50G can be achieved by multiplexing of virtual channels. And overall, to summarize, CLHS offers a road to continue higher bandwidth with minor tweaks of its protocol and IP core, as already mentioned, and it's designed for the needs of machine vision today and tomorrow. Thanks.
Thank you. Thank you. Next up, Chris Bainon for CoExpress.
Hi, I'm Chris Bainon of Active Silicon and chair of CoExpress. Now, CoExpress was designed originally for machine vision and to support the fastest cameras on the market. If you want to look at all the products, go to coexpress.com. So an update of where we are. Version 2.1 was released this year. The primary edition was Gen DC, that's already been mentioned. We've added that support. And as with the 2.0 released a year ago, we support up to 12.5 gigabits per second per cable. So that's typically 5 gigabytes per second on a real product. For product developers, with COVID, there's been a bit of a lack of meeting people, but there are remote plug fests to validate products, and compliance test sessions are still running. So one other new feature is CoExpress over fiber. From the name, CoExpress has always been a copper coax protocol, which works very well, definitely up to 12 gig. But looking forward, going towards 25 gig, fibers makes more sense. So we've already added this bridge protocol, which allows a well-proven deterministic CoExpress protocol to work over fiber. And as the next slide says, it gives us a roadmap to 25G. So already working on the updates for 25G. That should be out maybe this year, hopefully. And the other area, because we think 2.1 will be stable for some time to come, we're now working, the committee's working on improving product validation to make it easier for customers to use product. So nice and quick, there's an update for CoExpress. Thank you.
Thank you, Chris. Next up, for the rest of the GIA standards, Mr. Toshiaki Iwata.
I'm Toshiaki Iwata, Vice Chairman of JIA, Japan Industrial Imaging Association. This is the first time to have a speech in English, so I'm getting nervous. I would like to apologize for not speak smoothly and using poor English. Anyway, time has a limit. There are only 10 minutes for JIA. Let me start. I present JIA update and any information. We have a 6 working group. First, SLV SHE update. We have 2 standards. One is SLV SHE interface standard version 2.0. Version 2.0 adds support for higher date later. And version 2.0 is backward compatible with version 1.0. Test method for SLV SHE version 2.0. This document describes evaluation method of SLV SHE, confirms the physical layer characteristics. JIA member can download this document from the JIA website. And next, optical transmission media for machine vision. There are 3 types. Type A, max 12 core, empty type connector. Type B, small optical module. Type C, active optics liquid cable, hybrid cable. This is a type A, optical connector, MF11B. The fixture is 12 fiber. This type complies with international broadcast standard. This is a type B, suitable for a small camera. Height 3.5 millimeters and width 12.6 millimeters. Depth is 13.5 millimeters. Next, 2 types of SDR, HDR, AOC. This is a type C. One is a 14 connector core, and the other is a 26 core connector core. Common tentative specification, 10 gigabps per channel, transmission lane, hybrid cable with optical fiber and metal wires. Power line, DC 12 volt and 1 ampere. Transmission length, max 30 meters. Timeline, type A and type B is up to goal, and type C is now changed to AOC. Next, cable and connector certification. There are many problems using cable with connector in machine vision field. One reason is no evidence in bad environmental. So JIA has started cable and connector certification working group since 2019 to support for many machine vision companies. Now we have started from the variation and vibration. One, evaluation of vibration influence based on assumption that vibration wasn't jitter. Next, current status. Target cable and connector is CXP12 cable with both micro BNC connector. First trial evaluation is July 2021 at Tokyo Metropolitan Industrial Technology Research Institute. Goal for vibration influence is version 1.0 to March 2022. Next, lens mount. Lens working group, there are lens mount standard. And LE006 2016 NFJ mount standard and operational regulations is under revision work. And we have designed the lens mount logo from the last year. And finally, we decide logo, such as here's 6 variations. So we use this logo. And we examine the large size lens mount because recently machine vision camera resolution become higher and sensor size bigger as well. So this is a bigger size lens mount standard. Next, IIDC2. IIDC2 version 1.0 released and no outstanding progress. Gathering idea for version 1.3. Next, lighting. Updates since spring and summer 2020 moved the discussion forum on OPC UA impact to lighting device from lighting working group to a new working group. Collaboration advancement small working group in steering committee to collect broader opinions. Next, plan and hold a workshop seminar of GenCam implementation for lighting device. This is just done last month, and start regular review of existing standard and guidelines. Referring VDMA 2632 Part 1 regarding design description of illumination. These are three lighting standards, GRL 001-2018, and GRLIR 001-2017, and GRLIR 002-2017. Okay, that's all for me. Thank you for hearing, and please visit ZIA booth. Thank you.
Thank you, Iwata-san. Your English is fine, so you don't need to worry at all. Next up, James for GigiVision. Thank you. Is what? No. You can try? No? Yeah.
Hi everyone, my name is James Foster. I am Vice Chair of the GigiVision Technical Committee. Just going to give you an update today about the current state of GigiVision as well as some of the next steps that we're planning. So GigiVision 2.1 is our current released specification. It was released in the fall of 2018, I believe. The main features are multi-part transmission for sending 3D data, the introduction of some test features to help improve interoperability with some aspects of the standard. We introduced a new profile for precision time protocol, and we redacted some pixel formats that were defined in the specification itself in favor of referencing the GenCam pixel format naming convention. So for GigiVision 2.2, we've been working on it for quite some time now. We hope to have it out by the end of this year. There's currently a release candidate version 3 of the spec available, which has been in discussions and under review for the last several months now. We're working to get the GigiVision validation framework in line with the GigiVision 2.2 specification before it's released, so that we can have that enhanced interoperability and ensure things work when the spec is released. The main features for that are the introduction of GenDC streaming, as well as the inclusion of multiple event data. So going beyond that, going beyond GigiVision 2.2, our next big task is to look at speeds beyond 10 gigabits per second. There's some limitations with some of the current existing off-the-shelf technology, and we're looking at ways to adapt some other means of managing that. So that's what we're looking at in terms of the future currently. That's it.
Thank you, James.
Thank you.
Next up is Dr. Björn Jene for EMVA 1288.
Yes, thank you very much to everybody here listening. We will come finally to an exciting other topic, namely the EMVA 1288 standard for the objective characterization of image sensors. And my name is Bernd Jene, and I am the chair of the EMVA 1288 standardization group. And I have actually really exciting news for you, because a new release 4.0 has been issued in June this year with significant extensions to really adapt to all the modern image sensors. We have split the standard actually now in 2 modules. One is a new module, a released general, which is applicable to nonlinear cameras and also any camera which has pre-processing in it. We continue, of course, the old version 3.1 in the release 4.0 linear, which is basically a small improvement of the release 3.1. In these 2 modules, in general, as I said already, we no longer rely on a linear model or on a photon transfer curve. But the interesting thing is, even since we have a different module, or actually no model at all, we measure just an input-output relation in a kind of a general system approach, we can still measure all the 1288 parameters you are used to. So nothing is actually changing. We still are measuring the signal-to-noise ratio, the absolute sensitivity threshold, saturation capacity, input dynamic range, non-uniformities. The only thing which is no longer available in the general model is the quantum efficiency and the system gain, which is only a really relevant thing for a linear model. Still, we can measure, of course, a relative quantum efficiency. In the linear model, we also made a significant, or for both models, we made significant improvements. Wavelengths includes now UV and also shortwave infrared. You can actually measure the raw data of any modalities with the linear characteristic curve, multispectral sensors, polarization sensors, time of flight sensors. You see a lot of new things have been done. We have also adapted to more the CMOS cameras to do a more detailed specification of the non-uniformities. It's now split into pixel, row, and column variations. So we have a much more detailed measurement here. And we have also introduced a new robust measure for non-linearities and of the characteristic curve. Also, since image sensors, as you all know, are very diverse and complicated elements, it is important that we also do an education program. So the EMVA has decided to do a certificate education program. What is already running is a certification for all of those who want to do the measurements and can be certified as 1288 experts. We have already so far granted already, actually it's gone up already now to 51 instead of 46 as it's here, which are now 1288 experts. We will start in this winter also a certification program for all of those who want to learn and understand how the data sheets are, so who have to decide which is the best camera for our application. And there is actually a series of free webinars where you see the link here. So thank you very much for your attention. If you have further questions, you can always contact me. Thank you very much.
Thank you, Dr. Yene. So last but not the least, I will present the standards update for the VDMA standards, the first one being OPC machine vision. So OPC machine vision is the OPC UA companion specification for machine vision and the Industry 4.0 standard. Many of you might know Part 1 is already released since 2019, September. We are working on Part 2 right now, which deals with condition monitoring and the asset management parameters. And the total working group meetings are synced with the IVSMs. So we expect our draft for Part 2 to be there until the end of this year, hopefully. And at the same time, the OPC Machine Vision Core Working Group is working with the other OPC UA companion specifications groups, for example, OPC UA for robotics, OPC UA for machine tools, and so on, so that it all works in the end with the Industry 4.0 interoperability concerns or use cases. Next up is VDI, VDE, VDMA 2632 series of guidelines. Here I have just small updates. So Part 1 has currently been updated, and you can reach the group, or you can write if you have some recommendations or some corrections to the standard up until December. And part 2, the current activity is the work on the update has been started in September 2021 and will go on until a draft is ready. For the part 3, 3.1, and 4.1, there are currently no activities planned and are going on. So that's it from our side. I thank all my speakers who could somehow make it in time. And I hope this was of interest. We have the demonstrators and everything nice and fancy on the International Vision Standards booth, which is in this hall, B50. For OPC machine vision as well, you get to see a live demonstrator, live hardware demonstrator there. So if some of people are interested, please join us on that booth. Then that's it from my side. Thank you very much for listening.